Children's syllabus for 2023 is out, and this is physics syllabus for ISC class 12. Now this year in 2023 we will have only one exam as we were used to do earlier. 3 hours paper, 70 marks theory paper, 15 marks practical, 10 marks project work and 5 marks practical file. Then come to the topics in the syllabus. Electrostatics and current electricity. This will have 14 marks questions. Magnetic effect of current and magnetism, electromagnetic induction, alternating current and electromagnetic wave. These 3 topics together will have 16 marks question. Optics will have maximum weightage, 20 marks question. Then in modern physics, dual nature of radiation and matter, atoms, that is Bohr's hydrogen atom, and nuclear physics. Modern physics will carry 13 marks question and semiconductor will carry 7 marks question. Now let us come to topics here. Any topic which is not in the syllabus, I mentioned it with red ink separately. The highlighted part is that part which was not in the syllabus in 2022, but this year it is very well in syllabus. So let us start with the electrostatics. Carefully observe Coulomb's law, permittivity of free space, dielectric medium's permittivity, quantization of charges, and Coulomb's law in vector form. This whole part was earlier also in the syllabus and this year also it is in the syllabus. Then superposition principle means force between the two charges or more than two charges using the vector law of Coulomb or vector property of forces. Then electric fields concept, electric field due to one point charge, then electric field due to group of charges using the vector property of electric field which we call superposition principle. Then intensity due to continuous charge distribution, wire with a charge, a surface with charge and a volume like a spherical charge distribution. Electric field due to these 3, linear charge density, surface charge density and volume charge density. Calculation using Coulomb's law, its introduction is there. From this part, the difficult questions are never being asked. Then electric lines of forces, properties of electric lines of forces, then isolated point charge, electric field lines due to isolated point charge positive and negative, electric field due to dipole, then electric field lines due to similar charges placed at small distance, and then electric field when two oppositely charged parallel plates are placed in front of each other at a small distance. So this is electric field lines, their properties as well as the diagram in which you have to show the electric field lines in these cases, and from this part question is asked. Then electric dipole. Dipole moment of electric dipole, electric field of electric dipole at its axis, end on position, and on perpendicular bisector, that is broadside on position of a dipole, calculation of electric field in these two cases. When dipole is placed in uniform electric field, then what is the behavior of dipole? Torque acting on that dipole, derivation of this expression. This is all about electric dipole which is in the syllabus, and from this part questions are very important. Frequently asked questions from this part. Then Gauss law. First, what is flux? What is area vector? Then statement of Gauss theorem. Then Gaussian surface and its essential properties. Then application of Gauss law. Application of Gauss law contains electric fields calculation when infinitely long wire has charge, then uniformly charged infinite plane thin sheet, and then thin hollow spherical shell which is uniformly charged, its electric field outside the shell, on the surface of the shell and inside the shell, and graph of this electric field with the distance. So this part, shaded part, was not in the reduced syllabus of previous year, but this year this is very much in the syllabus. After that, the next topic is electrostatic potential and potential energy, and along with it the topic capacitance. Now observe the specific topics here: concept of potential, potential difference and potential energy, equipotential surface and properties of equipotential surface. After that, you have to derive expression for electric potential due to a point charge. Graphical variation of electric field and potential with distance r. The formula of potential difference, which is work done in transferring charge from one point to other, and potentials calculation for collection of charges, not for only one charge, for collection of charges where it is algebraic sum of potential due to all the charges at some specific point. Then potential due to dipole on its axis and on equatorial line. Then calculation of potential energy of a point charge which is placed in electric field. Then electrostatic potential energy of system of two charges, and then for system of more than two charges. That means you should know how to calculate potential energy when group of charges is placed at some distance. Then electrostatic potential energy for a dipole which is placed in uniform electric field. You have to derive its expression P dot E. And then potential energy when dipole is placed at 0 degree from the electric field, at 90 degree and at 180 degree. Then topic comes capacitance. You need to know what is capacitance. Then what is capacitance of parallel plate capacitor, derivation of this expression. Then equivalent capacitance when capacitors are in series and parallel. That means derivation of equivalent capacitance. Then derivation of energy stored in a capacitor, this expression's derivation. After that, what is dielectric constant or relative permittivity. How dielectric when placed between the plates of capacitor polarization occurs, and that affects the electric field between the plates of capacitor plates. And how induced charge reduces electric field and potential difference between the plates of capacitor. Then if capacitor is filled with dielectric and it is not connected with the battery, then what is the situation? And when capacitor is filled with dielectric but it is connected with the battery, then what is the situation of electric field, charge, potential difference and energy stored in the capacitor. The last topic of capacitor is when partially dielectric is filled between the plates of capacitor, then what is capacitance of the capacitor. Then current electricity starts. First mechanism, that is the flow of currents mechanism on basis of electronic theory of matter, mobility and drift velocities concept, relation of drift velocity with current, how this concept or this phenomena derives Ohm's law, and resistance and resistivity based on the electronic theory of matter or conductor. Then relation of drift velocity with resistance and resistivity, VI characteristic of conductor and semiconductor, linear and non-linear. Then temperature dependence of resistance and resistivity, basis will be the same, the mechanism or electronic theory of matter. Then internal resistance of a cell. Then concept of potential difference between the two terminals of the cell and EMF of the cell. What is difference between these two, terminal voltage and EMF. Then what will be the effect on the circuit if combination of cell is taken in series or in parallel. Then Kirchhoff Law and its simple application. Wheatstone bridge, meter bridge, potentiometer, principle of these three devices, their application, especially potentiometers, application to calculate potential difference between 2 points, application of potentiometer to compare EMF of two cells, and application of potentiometer to measure internal resistance of the cell. During this study, current density quantity will be introduced. This relation between current and drift velocity, this is very important derivation. Along with it, resistivity and its expression on the basis of the electronic theory of conductor. The vector form of Ohm's law, its derivation. After that, electrical energy consumed in a resistance when I current flows for t seconds. This part we have already done in class 10th, and questions almost similar to that are being asked, and this part is important because almost every year one question is being asked from this part. Here let me recall you that all these topics I have already uploaded, explanation of these topics already uploaded under the heading of Electrostatics, playlist is there, Capacitor, playlist is there, and current electricity playlist is there, and link will be provided in description box. Then this derivation of equivalent resistance when resistances are connected in series and parallel. The red ink content is not in the syllabus now. After that, the same explanation is in detail here. So we have already gone through it. You can pause video and you can go through it once again, and PDF of this syllabus I will upload on my Telegram channel. Link will be given in the description box. My handwritten notes are also available on the Telegram channel. The topic which I am going to now include that will be notified to you if you subscribe that Telegram channel. Now come to the topic magnetic effect of current and magnetism. This also is already uploaded under the playlist Magnetism. Concept of magnetic field, Biot-Savart's law, Ampere's circuital law, application of Ampere's circuital law to infinitely long straight current carrying wire and a straight solenoid. Force on moving charge, that is Lorentz force in uniform magnetic field and electric field. Force on a current carrying conductor when it is placed in a magnetic field. Then force between two parallel current carrying conductor, and on basis of this, definition of Ampere. Then torque experienced by a current carrying loop which acts like a magnetic dipole when it is placed in uniform magnetic field, and everything about moving coil galvanometer, its sensitivity, how it is converted in ammeter and voltmeter. So this is magnetism, and then magnetism and matter. In this part, the magnetic field intensity due to dipole, that is bar magnet on axis and equatorial line. This was not in the syllabus last year, but this year it is in the syllabus. And when bar magnet is having magnetic field lines and it is compared with the solenoid, then comparison is in the syllabus based on the solenoids and bar magnets magnetic field lines. What are electromagnets and what are the factors which affect electromagnets performance? Here, magnetic material is a very big chapter. Diamagnetic material, paramagnetic material and ferromagnetic material. Now this is not in the syllabus. It was not in the syllabus last year also, and it is not in the syllabus this year also. Also, when we are studying Lorentz force, cyclotron was in the syllabus 2-3 years before, but now it is not in the syllabus. So whatever I have written with the red ink separately, that part is not in the syllabus. So please mention it, that if it is in the book, you don't have to go through it for your ISC board. Here, derivation of IL cross B and derivation of torque NIAB sin theta. These are very, very important derivations, and Lorentz force definition is also very important. Then one big chapter topic is not in the syllabus now, and that is Earth's magnetic field. It is not in the syllabus. Now the next topic starts electromagnetic induction and alternating current. In electromagnetic induction, Faraday's law, Lenz's law, what is induced EMF, what is eddy current, what is self-induction and mutual induction, and information about transformer. These are in the syllabus. Then in alternating current, what is peak value, what is average value, and what is root mean square value of alternating current or voltage. Along with it, what is reactance and impedance in alternating AC applied circuits. LC oscillations, only introduction or explanation is required, and only qualitative treatment. And then LCR series circuit is very, very important. One question is always there in paper from this topic, and in this, what is resonance, what is power consumed in AC LCR circuit, what is wattless current, and then AC generator is in the syllabus. After that, magnetic flux concept, change in flux, then rate of change of flux, and how induced EMF is related with the rate of change of flux, that is Faraday's law in detail. What is motional EMF? This is also one topic which is every year in the paper. And then power required to keep the conductor moving in magnetic field so that this EMF is generated continuously. And eddy current, obviously, it is also very important. Then self-inductance formula derivation, mutual inductance formula derivation for infinitely long solenoid, and transformer, in it, principle, working, uses of transformer, step up, step down, efficiency of transformer, and energy losses and their prevention in transformer. Then derivation of V and I for only capacitive circuit, only resistive circuit, and only inductive circuit. Reactance, inductive reactance and capacitive reactance and their variation with frequency. This is very, very important. And analysis of AC circuits based on phasor diagram, very important. Then in LCR series circuit, you have to use phasor diagram only to analyze this circuit for every point. In LCR circuit, variation of impedance with frequency and current with frequency at resonance, very important. Power consumed in LCR circuit, very important. Bandwidth and Q factor for LCR circuit. Resonance frequency and average power consumed by LCR circuit over a full cycle. Derivation of this formula and what is power factor. What is wattless current, and for LC circuit only where resistance is not there, for LC circuit the simple analysis. It is very, very important topic. Here these some points like how choke coil controls the current in the AC circuit without having any power loss. Very important. Derivation of resonant frequency. Very important. And then AC generator, its principal working uses and basic difference between AC and DC. Now in electromagnetic waves, idea of displacement current was not in the syllabus last year, but this year it is in the syllabus, although it's only introduction, but yes, it is in the syllabus. And then electromagnetic waves, its spectrum, its characteristics, their uses, all in the syllabus as it is. Then in optics, everything is in the syllabus as it used to be, like reflection from mirrors, mirror formula, then refraction at plane surface, total internal reflections concept, its application, that is optical fiber, then refraction at spherical surfaces, lenses, lens maker's formula, magnification power of lens, combination of thin lenses in contact, combination of lens and mirror, refraction and dispersion of light through a prism. Everything is in the syllabus except scattering of light. It is not in the syllabus. Then optical instrument, microscope, astronomical telescope, both reflecting as well as refracting, and magnifying powers, derivation for all three. I will make available PDF of this syllabus, so you can go through it separately also. And then here one more topic is not in the syllabus. Optical instruments, resolving power is not in the syllabus, which was earlier in the syllabus. Now come to wave optics. In wave optics, first is Huygens principle, wavefront concepts. What is Huygens principle? Proof of law of reflection and refraction using Huygens principle. The whole topic interference, which is mainly concentrated on Young's double slit experiment. Then fringe width expression derivation, essential requirement for interference coherent sources, and then diffraction, that is Fraunhofer diffraction due to single slit, and width of central maxima. Here also one very big topic, polarization, is not in the syllabus. Then comes modern physics, wave particle duality, photoelectric effect, Einstein's photoelectric equation, particle nature of light, matter wave, that is de Broglie's relation of wavelength and momentum. Here Davison and Jummer experiment and X-ray. X-ray is a big topic which is not in the syllabus now. Then in atomic physics, Bohr's theory of hydrogen spectrum, Lyman, Balmer, Paschen and Brackett-Fund series. Then Rydberg's constants concept, expression or derivation of expression of orbital velocity, kinetic energy, potential energy of electron which is orbiting around the nucleus, and radius of orbit of electron, and total energy of electron orbiting around the nucleus. Then how to draw energy level diagram to show these transactions between the energy states, and then frequency emitted when electron moves from one state to another, and wavelength of different lines emitted in the spectrum when electron moves from higher to lower energy states. Here the thing is important that nanometer they are asking to use in place of Armstrong as the unit. Then in nuclear physics, mass energy relation, what is mass defect, what is binding energy per nucleon, variation of binding energy per nucleon with the mass number, nuclear reactions, nuclear fission, nuclear fusion and nuclear reactor. These all are in the syllabus as it is. Radioactivity is a big topic which is not in the syllabus from last 2 years, and this year also it is not in the syllabus. Then the last topic, that is electronic devices. Here the energy band diagram for difference between conductor, insulator and semiconductor, concept of intrinsic extrinsic semiconductor, concept of electron and hole in semiconductor, concept of majority minority charge carriers, N-type, P-type semiconductors, doping, donor and acceptor atoms, about the semiconductor, these points. Then junction diode, what is depletion region, potential barrier, forward and reverse biasing, VI characteristics of junction diode when it is forward biased and reverse biased, and numericals based on this concept. And then its use as half wave and full wave rectifier, simple circuit diagram, input and output signal. In this topic, very important topic, Zener diode is not in the syllabus now. And a big topic, transistor and gates, which you already study in computer, these two are also not in the syllabus. Then solar cell, photodiode and light emitting diode and their uses. These three are very important syllabus topics in the syllabus. And communication system, this whole topic is removed from the syllabus. So this was about theory paper. Children, about practical, as all the practicals which have been asked till now, I have already demonstrated, and how to write it in your practical copy. along with the reading, graph, explanation, how to draw graph, how to take a reading, its demonstration, and how to write reading. Every single aspect of practical is already uploaded in the playlist Class 12th Physics Practical ISC. So for practical, I will go through the information in a separate video, and all the theory topics are also uploaded with the explanation, and its PDF, handwritten PDF of my notes is available on my my Telegram channel, and I will give link in the description box. So you can get benefit of this help, and may God bless you and you do very well in your coming exams.